In this video, we're continuing with the theme of thermochemistry and looking at enthalpy. Enthalpy is just the sum of internal energy of the system and the product of pressure and volume. So enthalpy equals energy plus pressure times volume. And enthalpy, like energy, is a state function. Doesn't matter how we change enthalpy, it just matters our beginning and our ending enthalpy. So if we just deal with constant pressure, which we deal with a lot in chemistry, unless you're working in pressure volume work specifically, we can normally say, okay, we're in a lab, the pressure of the atmosphere is not changing, we're at constant pressure. Delta H is just really heat. All enthalpy really is heat, okay? And usually delta H and delta E are similar in volume unless we make or use large quantities of gas. But for enthalpy, just think of it for right now in Gen Chem as heat. So if we have a reaction in which delta heat is negative, heat is released by the system and it's exothermic. Heat is leaving us. So, for example, when we blow up a bomb, you can see this cloud of fire, we're releasing a lot of heat. However, if delta H is positive, then heat is being absorbed by the system. It's endothermic. So, cold packs, the way cold packs work is that you have water, film, and then a salt. You break the film and the salt goes into the water, and that absorbs heat from the surroundings, and it will be endothermic. Delta H is positive. Alright, so let's see if we can figure out the signs of delta H for water boiling, breaking bread, and burning a candle. Okay, so water boiling, baking bread, and burning a candle. In all three reactions, heat is going into our system. So it's an endothermic, process, and enthalpy is all positive. And that's all we have for enthalpy. Like I said, enthalpy is heat. Does heat go in? If so, it's positive, or does heat leave? Then it's negative. And that's it for this video. See you in the next one.